Okay, we will start another video about AC circuits. We have completed the DC circuits. We'll apply the same theorems we used on DC to AC circuits. But let's start with the basics of AC. AC means that either the voltage or current change with time. So if we draw the let's assume this is time, and we have a voltage here or current, voltage or I, or the current. Okay, in this case here, the value is constant, then this is DC. Okay, why? If the voltage or current change with time, then this is AC. Okay, so V is function of time. This is V or I. Then this is AC. So AC means equal alternating current. It is usually custom that alternating current changes direction. Okay, means half a cycle is positive and another half cycle is negative, like this. This is AC. AC, this is positive and this is negative. Say this is voltage. Okay, now in AC circuits, we usually have a sinusoidal waveform. So I or V. So here is time in seconds, and we have voltage V in volts. Alaykum salam. In volts. So this is an AC but sinusoidal waveform. So V as a function of time is equal V maximum sine omega t. Okay, so this is V maximum here, V maximum. Okay, now this is a complete cycle, tau. So tau is equal period or t. Let's assume this is t, not tau, t. Let's call it t, period. Then omega times t is equal 2 pi, equal 1 cycle, which means that t is equal 2 pi divided by omega. Now omega, we call it radian frequency. The unit is radians per second, and this is equal 2 pi times f. So f equal frequency. It is cycles per second, or we call it hertz. Okay, so if we substitute that, it means t is equal 2 pi divided by omega, which means equal 2 pi divided by 2 pi times f. So t is equal 1 over f. Okay, so that's the meaning of frequency or radian frequency omega. F is in hertz or cycles per second. It is speed. Okay, like we say the speed of, or the velocity of a wheel is, let's say, 3,000 revolution per minute. It means that per second you divide by 60, that will give you omega. Okay, or f in cycles per second. Now, knowing this, V is V maximum sine omega times t, or I equal I maximum sine omega ot, or we can use cosine instead of sine. These are sinusoidal waveforms. Okay? Now, let's assume that we have a resistance R, and we apply a voltage here V DC, and we obtain I DC. So what is the power? Power of DC is equal R I DC squared. Okay? Now, if we have the same resistance, R, same resistance, and we have a source here, plus minus V of T, will give you IAC. Okay? IAC equal I maximum sine omega T. Okay? This is the same. So what is the power AC is equal R IAC squared. So it will be R times I maximum squared sine squared omega T. Okay? Now, if this is the current I as a function of T, then this would be the current squared. So this is IAC squared. Okay? And you have here V maximum squared, and here you have, we're talking about a current, so it is I maximum squared. Okay? I maximum squared, and here we have I maximum. Okay? Now if we want to take the average, okay, of the power, here will give you I average, okay, I squared average. Okay? Now power is simply power is equal R IAC squared, and it has an average value, P average. If we calculate the P average, what is the P average? Okay, is equal PAC average. What we do, we integrate PAC dt, and from 0 to T, full period. So if we do that, it would be R I maximum squared, okay, sine squared omega T dt from 0 to the period. If we do that, it will be R I maximum squared over 2. You try it and check it, and you'll find it is the same. Okay? Now, assume power DC average is equal to power AC average. Therefore, RIDC squared should equal R I maximum over 2 squared. Okay? Now, R will disappear with R, so IDC squared is equal half I maximum squared, which means IDC equal I maximum over 2. Okay? So, if we have a current, a power AC, okay, a resistance R, what is the value of a DC current? This is IAC, okay. If we have the same resistance R, What is the value of IDC equal what to give PDC equal PAC average. So if we have an AC circuit, what is the value of the DC current that would give you the same average power of the AC? So IDC in this case, we call it is I maximum over root 2. Okay? This name is the root mean square of I or RMS. So IDC equal IRMS, which is I effective. It's the same. Therefore, IDC is equal IRMS is equal I effective. Effective is equal I maximum over root 2. This is if we have a sinusoidal waveform. Generally, IRMS is equal the integration from 0 to t of IAC squared dt divided by t, and we take the root. Okay, so this is the RMS value. Compared to average, I average is equal to integration from 0 to t, okay, of IAC dt, okay, and we divide by t. For I equal I maximum sine omega t, I average equal 0. Why? Because we have two half cycles of equal area but opposite sign. This is positive and this is negative. So if we take all the area, we integrate from 0 to t here, okay, then we have positive area and negative area, and the sum of this area 1, and this is area 2, we have area 2 equal minus area 1. So area 1 plus area 2 will be equal 0, which is integration from 0 to t IAC dt. Okay? So I average is 0. Therefore, for sinusoidal currents or voltage, V average equals 0, I average equals 0, but V RMS or effective value equal V maximum over root 2, and I RMS equal I maximum over 2. Okay? Now, when we come to these currents and voltages, we can represent them using time domain. When we say this, for example, V equal V maximum sine omega t plus theta. So that is the something like this. So the V as a function of t. So this is time domain representation. Okay? We can represent this as also a phasor form. Phasor form, we say this is V, and this is an angle theta. So we say this is phasor form, and V RMS. So what we have, for example, if V is equal, let's say 100 sine omega t plus 30 degrees. So this is time domain. Time domain. Phasor form, we say V, capital V, is equal 100 over root 2, but it has an angle, theta. So this is phasor form. Okay? So we replace V by V maximum, we divide by root 2 to represent an RMS value. So the length of V RMS of V vector or phasor is the RMS value, and it makes with the real axis an angle of theta. Okay? It's very important. Now, we take phase, what are phase relationships? Relationship. Phase relationship. Let's say V1 equal 200 sine omega t plus 30 degrees, while V2 is say 100 sine omega t, let's say plus 15 degrees. Okay? Then there is a phase relationship between both voltages. Okay? So if we draw a phasor, this would be V1 and this would be V2. So V2 makes 15 degrees and V1 makes 30 degrees. Now we say V1 leads V2 by 30 minus 15, which is equal 15 degrees. So V1 leads V2. Or we can say similarly, or V2 lags V1 by 15 degrees. So look at here V1 and V2. And the word leads, and this is leads. Okay? And here we have lags. And again we have V1 and V2. So we swapped, we made two operations. This is the same meaning as this. We can say V1 leads V2 or V2 lags V1 by the same angle. You see here, the same angle here, 15 degrees. So what we did is two operations. We changed the leads to lags and we changed V1. We swapped V1 and V2. So V1 leads V2 means if we want to change leads to lags means V2 we swapped. V2 lags V1. So we have to do two operations to give the same meaning. Let's say examples. Let's have some examples. If we say V lags I by, let's say theta. Okay? Now, we have the variables V and I, and we have the wording lags, and we have the angle theta. So if we want to change the argument by a different one, we must do two operations. Okay? This same means we can say I and V, so we brought this, we swapped V and I. This is one operation. We need another operation. We can change, for example, the lags to leads. Okay? So we did how many operations? Two operations. So we don't touch the other variable, which is theta. We say by theta. So it's the same, okay? The same theta, okay? So only two operations, or we can say V I leads. So what we did here, we did only one single operation. We changed the lags to leads, but we did not change V. We did not swap V and I. So we did only one operation. And the second operation, we can make it this way by, okay, by minus theta. Okay? So that's two operations. The first operation, we change lags to leads. The second operation, we change theta to minus theta, keeping V and I the same without swapping. So that's also correct. Or we can do the same here. Or we swap I and V and don't change the wording lags. So we did this operation, I swapped with V, but lags did not change by minus theta. We did the operation here, okay? So only two operations you do. In the first example here, the operations was the swapping I and V and changing lags to leads. So we keep theta unchanged. The second one, we did not swap, but we changed lags to leads and we changed theta to minus theta. That's correct. The third one, we did not change the lags, we kept it, but we swapped V and I, so that's one operation. And second operation is changing theta to minus theta. All these are correct, okay? Now, another example. What is the phase relationship of V equal, say, 200 sine omega t plus 20 degrees, while I is equal 100 cosine omega t minus, let's say, 10 degrees, okay? Now, be careful in doing the phase relationship, determining the phase relationship. Both signals must be of the same type. Either both are sines or both are cosines. You don't compare the two signals, one is sine and another is cosine. We have to change one to the other one. Either both are sine or both are cosine. Let's change the cosine to sine. Okay? We know that what is sine theta plus 90 degrees? We know this is equal sine theta cosine 90 plus cosine theta sine 90. This is 0. This is 1. So it is cosine theta, right? So cosine theta, if we want to change cosine to a sine, we add 90 degrees, i.e. V equal 200 sine omega t plus 20 degrees, we keep it. But I is equal 100 cosine omega t minus 10 degrees, we change it, 100 to sine. We take this theta all together, omega t minus 10, and we add to it 90 degrees, okay? So this will be 100 sine omega t plus 80 degrees. Now we compare this one with this one. Both are sines. And we can do the other way, changing the v to a cosine. Okay? It will give you the same answer. Now we can say simply v leads I, this is I, by angle of theta v minus theta I. We started v. V leads I. So we take the angle of v and subtract it from it the angle of I, which is equal 20 minus 80. So it is what? It is minus 60. Okay? So we can say v leads I by minus 60. Now, you may not like it that way. You want to change this minus 60 to plus 60. It's the same. Or we want to change this to plus 60. So that's one operation. The second operation, we can change, for example, leads to lags. We keep v and say lags I by plus 60 degrees, okay? Or plus 60 degrees by, I don't want to change the leads to lags. I want to keep the leads as it is. So I must then swap v and I say I leads v. This is correct. This is correct. This is correct. Anyone you choose of them is fine. Okay? Now, having known these things, now we will go to the response of the elements, resistors, capacitors, and inductors to an AC signal. Before doing that, in phase relations, if V and I, or V1 and V2, or I1 and I2, see the phase relationship is not necessarily between voltage or between currents. It can be also between voltage and current. Okay, in general, if V and are in phase, i.e., angle between both variables is 0, okay, we say that they are in phase. Okay, what does mean by in phase? It means that, for example, V1 and this is V2. Okay, V1 and V2, and this angle between them is 0. Or this is I1 and this is I2. So the angle of I1 and the angle of I2 is the same. Okay? Or the angle of V and the angle of I are the same. So in this case, we say I and V are in phase. In phase. Example, V1 equal 100 sine omega t plus 45 degrees. Okay, while V2 equal 200 sine omega t plus also 45 degrees. Okay, so because both they have the same angle, we say V1 and V2 are in phase. Okay, this is very important. Now let's go to the element response. Now first, resistor. Let's look at the resistors. We have an R plus minus V, and this is I. Then if I equal I maximum sine omega t, then V equal Ri equal Ri maximum sine omega t. Okay, so if this is V, you see I is in phase, okay? So this is V, this is I, okay? So this is V, this is I. V and I are in phase, okay? So for a resistor, this is Ohm's law. Ohm's law, okay? The voltage and current are in phase, which means that if this is I, then this is also V. They are both in phase. There is no difference in the angle. Now, if we take inductor, an inductor, this is an inductor, L plus minus V, and this is I. Now, V is equal L di per dt. Okay, di per dt. This is the condition or the law of an inductor, the voltage-current relationship. Now, if I is equal I maximum sine omega t, then V is equal what? L derivative of I maximum sine omega t with respect to t. Okay, so this will give you omega L I maximum sine. The derivative of a sine is what? Cosine. So it will give you cosine omega t. Now, omega, to determine the phase relationship between I and V, we must change this cosine to sine. So it will be I maximum sine omega t plus 90 degrees. Okay? Which means in phasor form, I is equal I RMS angle 0, which is equal I maximum over root 2 angle 0. While V is equal what? V RMS angle 90 degrees, which is V maximum over root 2 angle 90 degrees. Okay, now Ohm's law. Ohm's law says V is a function of I. We say impedance, Z equal impedance. Okay, units in ohms. V as a phasor equals Z times I. So we replace R with Z, okay? So Z is equal what? V over I. So in this case here, is V maximum over I maximum over root 2 angle 0 angle 90 degrees. Okay, so it will be V maximum over I maximum, and angle is 90 degrees, right? Now, what is V maximum? If we look, V is equal omega L, I maximum, sine omega t plus 90 degrees. So this is V maximum, okay? So Z is equal omega L, I maximum, that's V maximum, divided by I maximum, angle 90 degrees. So this will be omega L, angle 90 degrees. We can say it's J omega L, because angle 90 degrees is J, okay? We call it equal J XL, where XL equal reactance of inductor or coil. Units is ohms, okay? So V L equal JXL times IL. So if we have L, then we have an IL, and we have plus minus VL. The relationship between VI. Or the impedance is, in this case, IE, Z, impedance of an inductor is JXL, okay? In ohms. So it is complex. Now, if we take, before going to the capacitor, we can sketch them. If this is I, this will be V, and we have 90 degrees. So V leads I by 90 degrees. So if we have an inductor, the voltage leads the current by what? 90 degrees. Or the current lags the voltage by 90 degrees. Same meaning. Now, if we go to the third case, capacitor. This is C. Okay. This is plus minus V, and here I. Now the relationship is I equals C dV. Okay. So if V is equal V maximum sine omega t, then I is equal, it will be omega c times V maximum times cosine omega t, okay? Which is equal omega c V maximum sine omega t plus 90 degrees, okay? Now, if we compare V and I, okay, and say what is ZC equal VRMS divided by IRMS. The angle of IRMS, I, is 90 degrees. The angle of V is 0. Now, this is I maximum. This is I maximum. Okay? So this will be V maximum over root 2 angle 0 divided by I maximum over root 2 angle 90 degrees. So you obtain V maximum, okay, over root 2. So here V maximum angle 0, and here I maximum. I maximum is omega c V maximum, angle 90 degrees. Okay, so you get 1 over omega c and angle minus 90 degrees. Okay, so we call it this minus J1 over omega c, or simply minus JXC. Well, XC equal reactance of capacitor. Okay? So in this case, if this is I, if this is V, this is I, 90 degrees I. Or if it is I, this is V. Or, so, I leads V by 90 degrees. Or we can say V lags I by 90 degrees. It's the same, okay? V lags or I leads. So, in the case of a capacitor, the voltage lags the current by 90 degrees. While in the case of an inductor, the voltage leads the current by 90 degrees, okay? This is very important. Now, we can combine resistors, inductors, and capacitors in circuits. Let's say that we have a resistor, 10 ohms. We have a coil, let's say a 20 millihenry. And we have a capacitor, let's say 600 microfarad. And we want to obtain what is the value Z. Then, we must have a frequency, let's say 60 hertz. This is a frequency. So, solution. XL equal omega L is equal omega 2 pi times the frequency times 60 times L, which is 20 millihenry times 10 to the minus 6. We change the millihenry to Henry. This will give you, let me do it on the MATLAB, times pi times 60 times 20 divided by 1000, okay? That will give you 7.5, let's say 5.4 approximately ohms. Then we have to find also XC, which is 1 over omega C. So it will be 1 over 2 pi times 60 times C, which is 600 times 10 to the minus 6, because it is microfarad. So this will be 1 divided by 2 divided by pi divided by 60 divided by 600, then times, that will be, if you do it using your calculator, will be 4.42 approximately ohms, okay? Now, we can sketch the same circuit. Here we say, how many is 10 ohms, is that? 10 ohms, yes. 10 ohms. And we have a coil, we say XL here is equal 7.54 ohms. And we have a capacitor, we say XC here is equal 4.42 ohms. And we want now to determine what is the impedance Z, okay? Now, since it is a series circuit, so the impedance, total impedance is the impedance of Z1. Let's say this is Z1, say this is Z2, and this is Z3. So Z total is equal to Z1 plus Z2 plus Z3. What is Z1? It's 10 ohms. It's the resistance, because the resistance relationship between V and I, both are in phase. V is in phase with I in case of resistance. While if it is inductance, we say JXL. If it is capacitance, minus JXC. So this is Z1, this is Z2, and this is Z3. Okay? So this is equal to 10 plus J 7.54 minus J 4.42. So it will be 10 plus J 7.54 minus 4.42. So it will be 10 plus J 2 1 3. Okay, so this is the impedance seen by the circuit, which means that this is plus J, we call it inductive. We can represent this by an equivalent circuit of a resistance 10 ohms and a reactance of 3.12 ohms. Why reactance? Or why an inductor? Because it's plus J. This is an equivalent circuit. And this is inductive. Inductive, okay, because Z equal R plus JX, because here is positive. Okay? So we call it inductive. If it is negative, we call it capacitive. Okay? Now, we can say simply Z is equal 10 plus J 3.12. We can convert it to 10 squared plus 3.12 squared under the root and angle tan inverse 3.12 divided by 10. So if we have a value, let's say vector, this is C and this is A and this is B, okay, then we say simply C equal A plus J B. This is A, real part is A, imaginary part is B, and this is theta. So C squared equal A squared plus B squared. So C equal root A plus B squared, and B over A equal tan theta. Okay, so theta is equal tan inverse B over A. Okay, so we can say either C equal A plus JB or C equal absolute of C angle theta. So this is rectangular, polar, and this is here polar representation. Okay, you know this, and you go through the notes, is very simple. So we have Z is equal 10 plus J 3.12, which is equal 10 square. So let's say Z equal 10 plus J. In MATLAB you can easily calculate it. Okay, I'll just do that for you. Okay, that's 10. And you can go to the MATLAB and see what is the absolute value of Z. It will give you directly, so that will be 10.47 approximately, and angle will be in degrees. You can calculate it in degrees. Okay, it will give you times to convert it from, okay, this will give you 3024 radians. You can convert that to degrees, 10.47, and it will give you times 180 divided by, because in MATLAB it gives you the angle in radians, so that would be 17.328 degrees. Okay, so this is the way how we calculate impedances. Okay, another example, find Z total for this circuit, resistance 10 ohms, a coil here and a capacitor here. Let's say here 10 ohms and here 3 ohms. Now, in this circuit, already X, L and XC has been calculated. So I don't give you the frequency to calculate that. Simply you say Z total equal 10 plus J3 minus J10. Capacitor is minus J, so this would be 10 minus J7. Now the equivalent circuit for this, since you have minus G here, you say it's capacitor. Okay, because of minus J. The equivalent circuits are equal 10 ohms, and you have capacitance here of 7. Why capacitance? Because of the minus J. So it is equivalent circuit, and it is what? Capacitor. Okay, so when the impedance has a positive imaginary part or positive X, then we say it's inductive. When it is negative X, it's K capacitive. Okay, in general, Z equal R plus or minus JX. So plus gives you inductive. Okay, if minus gives you capacitive. Why? Show you why. Why is that? Why? Okay, let's see. If you have voltage source V and you have, let's say, an impedance, usually we put it in a rectangle because we don't know whether the elements are resistance and inductance or resistance and the capacitance. So Z, for example, R and inductance. So this is Z equal R plus JX. And if it is Z equal R minus JX, okay, then it will give you what? Resistance and the capacitance. Okay? Rx and here Rx. Now, so in Z here, it will be absolute of Z and Q minus theta. While here, it will give you absolute of Z angle theta. So, inductive gives Z absolute plus theta, while capacitive gives absolute Z and minus theta. Okay? Now, when we calculate Ohm's law, assume V equal V RMS, okay, angle 0, then I equal V over Z, okay? So, for inductive, I equal V angle 0, absolute of Z angle plus theta, so it gives you what? Absolute of I, angle minus theta. While for inductive circuit, okay, I is equal V angle 0 divided by Z, absolute angle minus theta, so it will be absolute of I, angle plus theta, right? So for an inductive circuit, let's say Z equal R plus JX. This is I, this is V. So if this is V, this is I. And it will give you minus theta. So I lags V for inductive circuit. Okay? If the circuit is inductive, I will lag. That's why we call it inductive. Okay? Now, if we have a capacitive circuit, Z equal R minus JX. Okay? Then this is I plus minus V. Then I will lead in this case. If this is V, this will be I. Theta. Okay? So here I leaves V for capacitive circuits. Okay, that's the main difference. Why? Okay, we call this capacitive and we call the other inductive. So what I want you is to read the notes, go through them, try to understand the phase relationships between voltage and currents and converting sine to cosine, cosine to sine. You have several examples over there. And apply them to find the resistance, the total impedance of a circuit with a parallel and circuits, and also find out how you add voltage and currents in a circuit, and find examples of KVL and KCL, Kirchhoff's current law, Kirchhoff's voltage law. For example, let's assume that you have a current I1, I2, and here you have I. 2 is known, and this is the direction. Let's say I equal 10 sine omega t plus 30 degrees, while I1 is equal to the sine omega t minus, let's say 10 degrees, okay? Find I2 equal what? So using KCL, we know that I equal I1 plus I2. So I2 is equal I minus I1, okay? Now this is equal, I is 10 sine omega t plus 30 minus I1, which is 2 sine omega t minus 10 degrees. How do we do that? Simply this I2 is equal I minus I1. This is time domain. We can transfer it to I2 equal I minus I1. This is phasor domain. Okay? So the operation, we change the time domain to phasor domain. So I2 is equal I. I is the phasor form of 10. So it is 10 over root 2 RMS angle 30 minus I1 is 2 over root 2 RMS angle 10 degrees minus 10 degrees. So it is minus 10 degrees. Okay? So this will be 1 over root 2. Okay? 10 angle 30. Okay? Minus 2 angle minus 10. You can do it by hand, or you do it by a calculator. To do it by hand, this would be 1 over root 2. This is 10 cosine 30 plus j 10 sine 30. Okay? Then minus 2 cosine minus 10 minus j2 2j cosine sine minus 10. Okay? So this would be 1 over root 2 10 cosine 30, okay, minus 2 cosine. So cosine minus is the same as cosine plus, so it's cosine 10, okay. So this is 1, then plus j. Here you have 10 sine 30. And sine minus is minus times minus is plus 2 sine 10. Or you can directly do it through MATLAB. So this will give you 1 over root 2. Let's do it. Okay, let's say that I have I V1 or I1 is equal 10 times, you can do it yourself, but I'm doing it through MATLAB, so I'll define V1 is equal 10 and angle 30 degrees, so this angle, say it is 1I times 30 degrees, so 30 degrees times pi divided by 180 to convert it to pi 180, that will give me I1, which is 8 point something plus j, okay. And let's go to I2. I2 is 2, okay, and this is minus 10, and get the minus 10, okay. So this would be equal V1 minus 2. If you do it, what I got, okay, I got 6.7 approximately plus j 5.35 approximately, okay. I got that value, okay, without dividing by root 2. Now this is equal 1 over root 2. Let's say this is, okay, V equal, I don't know, I hope I'm correct in doing this calculation, okay. So absolute value of that is equal to 8.565, and angle is, okay, angle is, angle of V is positive 38.636, okay. Which means that this is I2, this I2, right? I2 maximum, okay? And this is theta 2. So this is the RMS, I2 RMS. So I2 in time domain is the maximum, which is 8.565 sine omega 2 plus angle 38.636 degrees, okay. So this is the way how we do it in Phaser. First we do the operations in Phasers, okay, and then convert the final results to time domain, okay. So when asking find I2 in time domain, what we do, we convert this I to a phasor, we convert I1 to a phasor, do the operation, I to RMS equal I minus I1, and then finally convert the RMS value or the phasor form to time domain form. Okay? This is very important. Okay, you can apply it to KVL or so, you have in the notes. So I want you to practice these things, okay? Practice applying these to phasors. Then examine and read and read. Okay, series z equal what? Parallel z equal what? Okay, series parallel okay, z equal what? Okay, and also define admittance equal y admittance equal 1 over z, same as G equal 1 over R equal conductance. Okay, so Y it will be G plus JB. So this called conductance and called susceptance. Unit Siemens S, okay, which is equal 1 over Z. Okay, so admittance is the reciprocal of conduct or impedance. Okay, impedance has real value R plus JX. So here is resistance and here reactance. Okay, while Y equal 1 over Z will give you G plus JB. So here is what? Conductance and here susceptance. Okay, units in Siemens, while unit here is in ohms. Okay, Siemens and in ohms. I want you to read these things and apply it to the circuits. Okay, DC to the AC circuits, find series, parallel impedances. Okay, and then jump to the power triangle, or we call it what is apparent power, or we name it as complex power. Okay, in other words, if we have DC, power is RI squared. Okay, or power equal VI. This is very important. Watts. Okay, in AC we have power equal VI cosine theta and Q equal VI sine theta. How we obtain this? And S equal V times I absolute. This is the complex power. How we obtain it? In a vector, S equal VI conjugate, where this I conjugate is conjugate of I. So if C equal absolute C angle theta, then C conjugate is equal C angle minus theta. So So if this is C, then this is C conjugate, or vice versa, okay? So when apply this, S equal V, I conjugate, it will give you a complex. It will give plus JQ. Or S conjugate is V conjugate I, it will give you minus JQ, okay? S gives you volt, ampere, units. P units is watts. Q units is vars. Voltage, this is ampere, volt ampere, and this is reactive. Okay? So vars. And hence we get the power. This is P, this is a Q, and this is S, and this is theta. So S equal P squared plus Q squared root. Okay? And theta equal cosine inverse P over S, which is equal tan inverse Q over P. It's the same, okay? Because what we have, P equal S absolute cosine theta, while Q is equal S absolute sine theta, okay? Hence, S absolute equal V times I absolute, okay? So, P equal VI cosine theta, and Q equal VI sine theta, of course, absolute, okay? Absolute. Now, cosine theta is known as power factor, okay? Or FP. Now, for example, find the power factor. Alaikum salam. Factor if I equal, say, 10 amps angle 30 degrees, while V is equal 200 angles, let's say 70 degrees. Then the power factor is this is V, this is I, 30 degrees, and here 70 degrees, and this is V and I. So I lags V by 70 minus 30, okay, which is equal 40 degrees, okay? So in reality, the angle theta equal 40 degrees, angle between V and I. So FP equal cosine theta equal cosine 40 degrees, okay, equal, what is cosine 40 degrees? Cosine 40 times pi divided by 180 is equal 0.766, and we call lagging. Why lagging? Lagging because I lags V. If I leads V, we say the power factor is leading. Okay? So, I'll continue with you in another video how we apply theorems and methods of analysis, what we have taken DC to IC, okay? So good luck. Read and prepare. Okay? Thank you very much.